What are volcanic rocks? Volcanic rocks are a type of igneous rock that form from the solidification of magma or lava that has been extruded onto the Earth's surface or intruded into the Earth's crust. These rocks are formed through a process of melting, crystallization, and cooling, and can be found in a variety of forms and textures. Volcanic rocks can be classified into two main groups, extrusive and intrusive. Extrusive volcanic rocks, also known as volcanic or volcaniclastic rocks, are formed when magma or lava is erupted onto the Earth's surface and cools rapidly. This rapid cooling prevents the growth of large mineral crystals, resulting in a fine-grained texture. Examples of extrusive volcanic rocks include basalt, andesite, and rhyolite. Intrusive volcanic rocks, also known as plutonic rocks, are formed when magma cools and solidifies beneath the Earth's surface. The slower cooling process allows for the growth of larger mineral crystals, resulting in a coarse-grained texture. Examples of intrusive volcanic rocks include granite, diorite, and gabbro. Volcanic rocks can also be further classified based on their chemical composition. Basalt, for example, is a mafic volcanic rock that is rich in iron and magnesium, while rhyolite is a felsic volcanic rock that is rich in silica. Volcanic rocks are important in the study of geology because they provide valuable information about the history and processes of the Earth's interior. By analyzing the mineral composition, texture, and age of volcanic rocks, scientists can learn about the temperature and pressure conditions under which they were formed, the tectonic processes that led to their formation, and the history of volcanic activity in a particular region. Volcanic rocks also have practical applications in areas such as construction, as they are commonly used as building materials due to their strength and durability. Basalt, for example, is commonly used in road construction, while granite is often used in countertops and monuments. In addition to their scientific and practical applications, volcanic rocks also have cultural significance. Many indigenous cultures around the world have long-standing traditions and beliefs associated with volcanoes, and volcanic rocks have been used in art, ritual, and architecture for centuries. Overall, volcanic rocks are an important and fascinating component of the Earth's geology, providing insights into the planet's history and processes, as well as practical applications and cultural significance. What are the properties of volcanic rocks? Volcanic rocks have a wide range of physical and chemical properties that are determined by their composition, texture, and the conditions under which they were formed. Some of the key properties of volcanic rocks include texture. Volcanic rocks can have a range of textures, from fine-grained to coarse-grained. This texture is determined by the rate of cooling of the magma or lava. Rapid cooling of magma or lava at the Earth's surface results in fine-grained volcanic rocks, while slow cooling beneath the surface produces coarse-grained volcanic rocks. Mineral composition. The mineral composition of volcanic rocks can vary depending on the composition of the magma or lava from which they were formed. Common minerals found in volcanic rocks include quartz, feldspar, mica, olivine, pyroxene, and amphibole. Chemical composition. The chemical composition of volcanic rocks can also vary depending on the type of magma or lava from which they were formed. Mafic volcanic rocks, such as basalt, are rich in iron and magnesium, while felsic volcanic rocks, such as rhyolite, are rich in silica. Density. The density of volcanic rocks can vary depending on their mineral and chemical composition. Mafic volcanic rocks tend to be denser than felsic volcanic rocks. Color. Volcanic rocks can come in a range of colors, including black, brown, red, green, and white. The color is determined by the minerals present in the rock. Porosity. Volcanic rocks can be porous or non-porous, depending on their texture and the conditions under which they were formed. Porous volcanic rocks, such as pumice, have a high percentage of air pockets, while non-porous volcanic rocks, such as basalt, have few or no air pockets. Hardness. The hardness of volcanic rocks can vary depending on their mineral and chemical composition. Some volcanic rocks, such as obsidian, are very hard and brittle, while others, such as pumice, are soft and crumbly. Fracture. Volcanic rocks can exhibit different types of fracture patterns, such as conchoidal, smooth, curved, blocky, or fibrous. These properties of volcanic rocks are important for their identification and classification, as well as for understanding their formation and potential uses. For example, the density and porosity of volcanic rocks can affect their suitability as building materials or as reservoirs for oil and gas. The chemical composition of volcanic rocks can also provide insights into the tectonic processes and geological history of a region. Please don't forget to subscribe to my channel and turn on notifications.